limit as z goes to 4 of z squared minus 7z plus 12 divided by the square root of 2z plus 1 minus the square root of 3z minus 3. The first thing we're going to do is plug a 4 in for each of the z's. In the numerator, that gives us 4 squared minus 7 times 4 plus 12. In the denominator, that gives us the square root of 2 times 4 plus 1 minus the square root of 3 times 4 minus 3. In the numerator, 4 squared is 16. Negative 7 times a 4 is a negative 28 plus 12. In the denominator, 2 times 4 is an 8 plus a 1 minus, and 3 times 4 is a 12 minus a 3, each of those under the roots. In the numerator, 16 minus 28 is a negative 12 plus 12. In the denominator, we have the square root of 8 plus 1, which is the square root of 9, minus the square root of 12 minus 3, which is also the square root of 9. So we end up with negative 12 plus 12 over 3 minus 3, which gives us 0 over 0 indeterminate form. We'll have to rework this since we have a root combination, a root involving the variable z added or subtracted together with at least one other term. We can try the root conjugate method. The root combination may be made up of 2 roots, like here, and you still use a root conjugate. So I'm going to rewrite the entire expression just as we see it. And we're going to multiply by the conjugate. The conjugate is the opposite sign between them. That's a negative there. We're going to want a positive. We do not change anything inside of the roots themselves. We're going to put 1 in the numerator as well, so we have a form of 1. So we do not change the value, we just change the look. We're going to multiply these. So we have limit as z goes to 4. In the numerator, we will not FOIL that out. We're going to keep that factored since those are not conjugates of each other. So z squared minus 7z plus 12 times the square root of 2z plus 1 plus the square root of 3z minus 3. All of that over what will be root conjugates, so we will FOIL. Square root of 2z plus 1 times the square root of 2z plus 1 will be 2z plus 1 for the first. Square root of 2z plus 1 times the positive square root of 3z minus 3 will become a positive square root. They go under one root. This is the outside, and it will be 2z plus 1 and 3z minus 3. And then the negative square root of 3z minus 3 times the positive square root of 2z plus 1. This will be the inside. They can go together under a single root. And then the last is the negative square root of 3z minus 3 times the positive square root of 3z minus 3, which overall will give us a negative of 3z minus 3. It's really important to keep 3z minus 3 in parentheses, and watch that negative sign. We're going to be distributing that in. The outside and inside terms cancel, and so we'll take those out. Our next step is to distribute that negative sign in the denominator so we can combine together like terms. In the numerator, we're going to leave that alone. Z squared minus 7z plus 12 times the square root of 2z plus 1 plus the square root of 3z minus 3. In the denominator, we will have 2z plus 1 minus 3z plus 3. And we can then combine together like terms in the denominator. Limit as z goes to 4. Z squared minus 7z plus 12 times the square root of 2z plus 1 plus the square root of 3z minus 3 divided by, combining like terms, we have a 2z minus a 3z, that will be a negative z, and then a 1 plus a 3, that will be a plus 4. Now, root conjugate will never get rid of the 0 over 0. It just changes into a form where we have other work we can do to get rid of the 0 over 0. We still have 0 over 0. In the denominator, we're going to have a 0 when we plug z over 4 into there. In the numerator, we're going to have a 0 when we plug 4 in for z there in that expression. We will need to factor so that we can cancel. Since z is going to 4, I expect to see a z minus 4 as one of the factors when we do the trinomial factorization. We need two numbers that multiply to be a positive 12, so they're both positive or they're both negative, and they have to add to be negative 7, so they have to both be negative, and it sounds like negative 3 and negative 4 will fit that. And there's the z minus 4 factor that was expected. That kind of helps check your work. And then we have that sum of roots on the end there. And then denominator, I'm going to factor out a negative, since right now this expression is opposite sign of what we see in the numerator. So we're going to factor a negative out of it so that it becomes matching factor in the numerator. At that point, we can cancel the z minus 4 with each other. And it's going to leave us a 1 here times that negative. So we have a negative 1 in the denominator. Dividing by negative 1 is equivalent to multiplying by negative 1. And I'll just write it as multiplying a negative 1. I'll just put a negative 1 in the numerator. And so we've reduced it to this. We should no longer have the 0 over 0 indeterminate form. We should be able to plug in a 4 for each of the z's. So this would give us a negative of 4 minus 3 times the square root of 2 times 4 plus 1 plus the square root of 3 times 4 minus 3. So it's a negative of 4 minus 3 is a 1. And then we will have the square root of 2 times 4, which is an 8, plus 1, plus the square root of 3 times 4, which is a 12, minus 3. So we're going to have a negative times the square root of 9, plus the square root of 9. So negative of 3 plus 3, or negative 6.